All right, so we have a confidence interval for population mean. That's what we've been doing this chapter, section, whatever you want to call it. So number one, we have a cellular telephone company recently conducted research into length of calls. So this is going to be important for identifying what we're doing. Made by customers. In a random sample, random is always important. It's always good to know. 30 calls. Okay, you might be wanting to make these same notes on your paper while I'm doing this, because these are the things you want to look for when you're doing, any kind of assessment. It says the sample mean was 18.6 minutes, and the standard deviation was 5.2. Since it's the beginning of that line, I'm going to mark ST there as a reminder what that 5.2 is. Construct and interpret a 90% confidence interval for true mean call length. All right. So when we do step one, we just identify with our funky looking U. And, it tells us right here, pretty much, true mean of customer call lengths. All right, easy peasy. You're just looking for what we're studying. What is the study about? Okay, it's call lengths. So we're looking for the true mean of the call lengths. If you didn't put the word customer in there, no big deal. True mean of call lengths, whatever. Even if you just wrote this, true mean call length, just to get the general idea. Number two, we check conditions. So the first thing we always check for is random. Okay. Random question mark, check mark. And we say it was given to us because it was right up here. Okay. Second thing we look for, normal, question mark. And we say 30 is greater than or equal to 30, so check. And remember, it doesn't have to be greater than 30, it has to be greater than or equal to 30. So since we have 30, we're good. If it was 25, right here, we would say, proceed with caution. But we're still going to move on because it's just too much fun to deny ourselves. Number three, we're doing a 90% confidence interval. Okay. So our number is 18.6. Okay. That's our mean. Plus or minus. Okay. Now, hold on. All right. So right here, we need our T number. Okay. So we use our chart, which is in announcements again. Okay. Now, 90%, right? Now we're going to go up and look for our number. Now remember, the number we're looking for is n minus 1, the degrees of freedom. So how many people were in the study? 30, or in the phone calls or whatever, 30. So we don't want 30, we want to back up to 1, or back up 1 to 29. And where does 90 meet? Right here at 1.699. So remember, we're not using a z-score here. We're using a t. So we come back here, and we're going to write 1.699. Then this number here is the standard deviation, which we are given, divided by the square root of our number. If you want to write off to the side to remind yourself the degrees of freedom were 29, that's fine. Okay, I'm not going to show on the calculator crunching the numbers. It's going to be 18.6 plus or minus. This works out to be 1.61. So if I subtract 1.61, I get 16.99. If I add 1.61, I get 20.21. 2021. Okay. And then we're almost done. We just need to make our classic statement, which is a fill in the blank. We are, fill in the blank, 90% confident, and I'm putting the underlines there to remind you that those are the ones we're filling in. The interval, anything not underlined is just the standard stuff we write every time. The interval from And we're just going to fill in what's in the parentheses, 16.99 to 20.21 captures the true mean of, and we're going to fill in, and I'm just going to save some space here and just say call lengths. If you put customer call lengths, no big deal, whatever. Same thing. And that's it. That's the problem. Okay? So you have the formula, in your packet, but, it's very simple. You start off with the mean, plus or minus your t-score that you use the t-table to get. This is standard deviation. This is the square root of the number. All you do is fill in the numbers, crunch the numbers, get your range, and then pretty much copy the statement, filling in the blank. Part B, based on your interval from part A. And remember, the interval is right here. Whoopsie. It's right here. Okay, about 17 to 20, really. Based on your interval from part A, is there convincing evidence that the mean length of calls is not 20 minutes? Well, the answer is no. Because 20 minutes is within the interval. Barely. I mean, it's on the upper end, but you're also talking about pretty much a 3-minute interval. It's a small interval, but 20 is within the interval. Now, if this question said, is there convincing evidence that it's not 21 minutes? Yes, sirree. Because 21 is outside the interval. So it's just a very simple question. If this number that they ask you about is within the interval, then no, because it's in the interval. And if the number is outside, you go, well, yeah, there is evidence because it's not in the interval. A little bit of common sense. All right, number 2. Part A, 500 randomly selected working adults. I think we're okay on N. Living in Calgary. That's not the number of people, I don't think, though. We'll see. Canada, we're asked how long in minutes their typical daily commute was. Okay, so we're asked about their daily commute. The resulting sample mean and standard deviation were 28.5 and 24.2 respectively. So in other words, this one is the mean. Sometimes you have to read these a little bit. And then this one here is the standard deviation. Okay? So, it says, construct and interpret a 90% confidence interval for the mean commute time of working adult Calgary residents. So, since it didn't break down anything smaller than 500 answering, we're using 500 for our N. So, that's our N right there, 500. So, step 1, we write our funky U, and then we write true mean, that's an E. I'm just going to start that over. Even for me, that's bad. True mean of daily commute in minutes. And, you can go further. You can say, of working adults in Calgary, Canada. I mean, whatever. But it's basically the true mean of daily commute in minutes. All right. Number 2, we write random question mark. Okay. And we look for the word random, which I forgot to say. So, that's long. Resulting sample mean standard deviation commute time. Yep, there it is. Randomly. Boom. Randomly. So, yes, given. Reading is hard sometimes. And then we look for normal. Well, yepers, because 500 is greater than or equal to 30. So, we're good to go. That's all we do for 1 and 2. Very simple. 3, we get into the math. Again, we're doing a 90% confidence interval. But remember, we don't go like z-score, we can't go, oh, 90% is the same every time. Okay, remember, when we did z-scores, 90% was a number, 95 was a number every time. This time, it depends on the number of people. So we're going to start doing our math. We first need our 28.5, our mean, plus or minus. Now we got to find our t-score. So remember, 500 people, we're going to back up to 100. So we're going to look for the interval of 90% and 100, which is 1.66. Okay? So we come back here and we put in 1.66. All right? So key thing, guys, is here we're not using a z-score. It's not always the same number. It depends on the table. Then this part's easy because we use the 24.2 standard deviation, which was given right up here. And then we take the square root of 500. So the degrees of freedom is technically 499. But remember, we drop and use 100. So that's just more of a reminder about the chart, a reference. That's supposed to be a 9. Okay. Again, I'm not going to get out the calculator. I'm just going to crunch the numbers right here. 28.5 plus or minus 1.8. Actually, I will show it real quick because the order I like to do this in is not have my calculator explode. I like to have, it's very simple. I just type in 24.2. If I can find the 2. I divide by second square root 500. I get that number first. Then I multiply that by the 1.66. And I just round it. Okay? And the reason I use only one number is because it's technically 1.80. But if this was like a 1.73, I would have gone out to 7.3. Try to use 2, hundredths place. But since this rounds that up to 0 and 80, then I just put 1.8. All right? And then, very simply, I'm going to subtract and add. So 28.5 minus 1.8 is 26.7. 28.5 plus 1.8 is 30.3. And now we just get into our statement. We are, okay, 90%, we fill that in, 90% confident that the interval from, and now we fill in, I didn't mean to put parentheses, put an underline, because this is a fill in the blank, 26.7 to 30.3 captures, again, this is the same words every time right here, the true mean. And this we just copied from our funky U at the beginning of daily commute in minutes. Again, if you want to be more specific and say in minutes of working adults in Calgary, Canada, whatever, but that's good enough. You're just getting the general gist. And then we look at it and says, can you conclude the mean time of working adult residents is 30 minutes? Now notice, this question is looking for the positive, not the negative. The last one said, can you not do it? This one says, can you do it? So you got to be careful to look for the verbiage. It's not always going to ask one or the other, but basically it's saying, is 30 minutes within the range? And you say yes. Because 30 minutes, a little bit of lag here, is in the interval or within the interval. That was weird. And the last part, this is the other thing we were doing. This is different. This is not doing the whole 4-step procedure. This is trying to find the number. So, counselor wants to estimate the average number of text messages sent by students at his school during school hour. That's missing some English, but okay. He wants to estimate the funky U at 99% confidence level with a margin of error at most of 2 texts. There's words missing here. A pilot study indicated that the number of texts sent during school hours has a standard deviation of about 9 texts. How many students? So this is the other kind of thing we learned before. How many students need to be surveyed to estimate the mean number of texts sent during school hours with a 90% confidence margin of error at most 2 texts? Just repeating the stuff from the beginning. Okay? Now, remember, when we're trying to find out the number of people, we can't use the T chart per se because, well, we don't know the number of people to figure out the degrees of freedom. So we go to the bottom. It's frozen. Well, silly me. Thank you. So we go to the bottom of our T chart where the Z is. This is like the infinity Z. So we go over to 99%, just go right above it, and there's our magic number that we need, 2.576. So Z equals 2.576. You still use the T chart, you just go to the bottom row. Okay? And then it's 9 over the square root of n. Okay? Because 9 was a standard deviation of 9 texts. Now, well, I meant to separate that out. Sorry, my bad. Let's just change this here. We're going to make this get ahead. I was going to do 2 separate parts, but it doesn't really matter. So the number we're looking, the error we're looking for is 2 texts. Okay? I was going to say Z equals, then go do the formula, and I just jumped into the formula. So sorry about that. So that is the thing we do there. So first off, I'm going to multiply these 2 numbers because this is really over 1. So I'm going to get 2 equals 23.184 over the square root of n. And there's a little trick here. We did this in Algebra 2. We did this here in Stats. Instead of rewriting, doing a lot of work, we just switch them. And we can say the square root of n is equal to 23.184 divided by 2. So square root of n equals, divide by 2, you get 11.592. And then to get rid of square root, we just square both sides. So we're going to be over 100, obviously. And I just type in my calculator. 11.592 squared is 134.37. And we round up to what we need. So we need 135, that's a 5, students. So real easy math.